Okay, multiple zeros. So let's start off by talking about the multiplicity of a zero. Now, what this means is effectively that anytime you have a double up of a zero or a triple or whatever, the multiplicity is just how many times it happens. Okay, so for example, if we have a polynomial, so p of x is equal to x minus some root, or some zero, m, lots of some other quotient, where q of x is not equal to 0, okay, then what this is basically saying is that the polynomial p of x has multiplicity m at x minus alpha. This is all it's the same. So if I was to ask you what's the multiplicity of the alpha term, then you just say it is m. Okay, and that's all that means. Now, when we're trying to find the multiplicity of 0, what we can do is we can actually use the derivative as like a sort of helping hand. Okay, so if so let's say x is equal to alpha is a 0. Okay, and it has multiplicity. So of multiplicity, and we'll call it m as we do. So of multiplicity m. Okay. Then, or of multiplicity m greater than or equal to 1. So basically we're saying that it has a derivative. It has a multiplicity that's bigger than 1. So like let's say that there's two zeros that share the same value, or 4 zeros or something like that. Then what we can say is that x equals alpha is a 0 of multiplicity m minus 1 of the derivative of the polynomial. Okay, so basically if we find the derivative of a polynomial, then if we substitute that 0 in, it should give us a 0 as well. Okay, and it should work for every single time. So basically what I'm saying is if x is equal to alpha is a multiple root, then alpha is a 0 of the derivative of x. Okay, and basically the converse is true as well. So if x is equal to alpha is a single 0 of p of x, then it's not a 0 of p of the derivative of x, I should say. Now let's suppose that x of alpha is a 0 of a polynomial. Then if it's an even multiplicity, then the curve is tangent to the x-axis and does not cross the axis. Okay, so basically what that means is if we have like x minus 2 squared, x cubed, and x plus 2, something like this. So if we have a graph of this, and I ask you to graph it, okay, anywhere there is a multiplicity of even multiplicity, I should say, so that is that the powers, okay, so the powers in this one are even, okay, then what will happen on the graph is that there will be a tangent to the x-axis at that 0, but it will not cross the x-axis there, and therefore it's a turning point. Okay, so what I mean by that is if I draw this one up quickly, like this, okay, 1, 2, 2. Okay, so this first point is x minus 2. So at that value there, at the x is equal to 2, so this is the point over here. At this point here, what's going to happen is my graph's going to come down and meet this point here. Okay, and it's going to come back up like this, and it makes a tangent. So it makes a tangent that's parallel to the x-axis. Okay, so I mean it is the x-axis itself. The tangent makes it there. But basically this line here, if it was to keep going, it'd probably keep going like that if it was a non-even power. But because it's even power, it doesn't cross over that line, but it just comes back up like this. Okay, and we've talked about that before too, about the even, the odd powers. Now, if x is equal to alpha has a multiplicity of at least 3, then the curve is tangent to the x-axis at that point, but crosses the x-axis. Okay, So this one here, this x cubed bit. So basically what this is saying is it comes back down to the point here, it gets flat, and then it comes back down here. So that if we were to look at the tangent at that point there, so at that specific point, it would also be flat, but this line, or this part of the curve, crosses over the x-axis there, okay? Now that is when m is greater than or equal to 3, okay? And that's when m is even over this one. Okay, so that's that bit there. And lastly, we've got the, if x is equal to a is a simple 0, then the curve crosses there and there is no stationary point there. So at the x plus 2, that's this point here, so this one might come back across it some way, and it just comes straight through there, okay? So we call these stationary points, so at these points here, because what happens is, the when the graph comes down, it goes flat, so basically the rate of change stops, and it changes the other direction, or it keeps going, but it stops at that point. Okay, this point here and this point here would also be stationary points because they get to a point and they stop, and then they go back down the other way, or the rate of change comes to 0. Okay, so that's a pretty quick example of that and how that one works. Okay. And that's pretty much it for this. What we're going to be looking at in the next video, however, is the factorizing. So the factorizing now with this understanding of the multiple zeros. So I'll talk to you guys in the next one.